Hello. Let's do some programming, shall we? So we did some. Well, we did like a 4 chapters, almost 4 chapters. And we only had a couple. We only had a few levels left off without completely optimizing for the power number of lines. We spent about 8.5 hours last time. I think I'm going to spend up to like 6 hours today and see how far we can go. So, I did some solving offline actually, and I managed to get a subpar. Well, subpar is not the right wording, isn't it? Subpar implies that it is worse than a par, but what I mean by that is the number of lines is is lower than the what the par number suggests. So that's what I meant by subpar. Well, under par is a better wording, right? Under par. So this one, the par line is 13 lines. I managed with 11 here. So what I did here is I basically turned all instances of duplicate repeating characters into the one character following letter D. So for example, when you see a string A, 4 A's, that becomes DA. And if there is just one letter, so if it's just a letter A, it stays letter A. So after doing all those conversions, I then convert all A and B and C into letter E's. So after all of this, the string will just become a bunch of E's, and sometimes there will be letter D's in between. And what this means is, when you see any occurrences of DE, this must mean that this used to be a repeating duplicate characters. So we can safely remove them. And now the remaining letter E's represent, like each of those letter E's represent every letter that is different from their adjacent letters. So if there are 2 or more of letter E's, we return false. If there's just one E, we return true. And then if there is none, we also return false, because 0 is not 1. So this is what I did. So this is my second under par problem. So 2 out of 10, 8 more to go. And also, well, even though this doesn't really, even though this didn't really count towards the play time, I did manage to solve these ones, A to B3, half, and to be or not to be, and center. These ones I managed to get the par number of lines. Like, I don't have it here just yet. Wait, where did the thing go? Yeah, it doesn't matter, but I solved it with my notepad while watching my VOD. I think it's kind of a cheating because I did spend time solving the puzzle without increasing the playtime hours, but yeah, it's okay. I mean, if I really wanted to optimize, I wouldn't be even commentating or like bothering streaming anything. I would be just silent. It's just solving everything if I really cared about getting 100% as fast as possible. I mean, I'm still trying to get 100%, the faster the better, but I'm not going for a word record. I'm just trying to. mm, well, I guess I guess one of the primary things that I'm trying to achieve with streams like this is for me to improve at my commentating skills, improve at my English speech. I mean, I'm fine with English speech. I'm fine talking in English. I've been in the United States for many years, but when it comes to everyday talking, I could still use some learning because most of my English speech was based on my work environment, so like in the very professional environments. So when it comes to casual talking, I still have ways to go. I also need to improve at my pacing, improve at my making my accent more understandable, etc., etc. Anyways, let's try to get the par lines here. So in here we want to replace each A with B and replace each B with A. So we are swapping A's and B's. So what I'm going to do here is we have a string right here, and I'm going to insert a letter D in front. And what I'm going to do is I'm going to just move each character that's right next to letter D to the other side. So once you do this, after everything, the entire string will be on the left side of letter D, and then after that I just clean up the letter D, and then will be there. But while we are moving the strings across, this is where I'm going to do the swapping thing done. So in the form of the syntax, this is how it's going to look like. It first insert the letter D in front of the string, and now we are just going to move each letter to the other side of the letter D. But here I'm going to swap the letter A and B, and then afterwards I just clean it up. So this should work. I never tested it, but like I don't see why it would not. Yeah, exactly. So this is so that was A to B3 4-9 par done. Let's move on. So now we have the half 4-10. So in also in this one, I'm going to use the similar technique for iterating through each letter, but this time I'm going to be alternating between letter D and letter E. What I mean by that is, so we first start with letter D here and check and look what I do here. So when you see a letter A next to letter D, I move it to the other side. But when I do this, I swap the letter D with the letter E. So something like this, right? And then do the same thing with the letter E. Hey, Samag, welcome to the stream. So when you see a letter A next to letter E, we move it to the other side. So that becomes like AE, but I swap it with letter D, and then afterwards I clean it up. But notice where we want to remove each letter, right? We want to remove each letter at an odd position. So so for the so for this case, we do not want to have these letters remaining. So it's just going to look like that. Okay, this should work when I run this. Yeah, it works. We still need to remove one more letter, one more line though. So what I'm going to do is, um, let's see. We can't afford to remove any of these lines, can we? Yeah. I mean, I do have the par lines in my notepad. I'm just trying to remember it without looking at it. It says at top left what the par is. Also, not just in level select. Yes, I can see it says challenge colon at most 8 lines. I can say that. Okay, how about this? Instead of using letter E, I'm going to use 2 letter D's, right? So it's gonna look something like this. So if we do this, we can only decide to remove letter D, and that's just gonna do it. But we need to swap the ordering like this, so that when you see DDA, we don't want to proc DA first. We want to proc DDA first. So we had to swap the orderings. I think this one should work. Yeah, okay, it works. So that's the part line done. Let's move on. The next one is to be or not to be. So this one says if at least one B occurs, replace each A with B. Otherwise, replace each A with C. So we applied similar principles here. So instead of using letter D's and letter E's, we are gonna use letter D, and another letter D. So first, once we found a letter B anywhere in the string, we attach it to letter D, so that we know to move it to the start. Move it to the front of the string. So something like this. We also want to add another letter D here. So what this does is, if letter B was found anywhere in the string, now there are 2 letter D's in front of the string. Otherwise, there's just going to be 1 letter D, and we are going to use that as a conditionals to decide whether to swap the letter A into letter B or letter C. Okay, and as for the other letters, as for the letter B's and letter C's, we just get them through without changing anything. So for example, we can just do this, right? We can just move them through. That's fine. But once we see DDA here, like I mentioned, all letter D's indicate that there was a letter B at some point. So we want to change this into a letter B, just like this. Otherwise, we change it into letter C. But the ordering is important. I think we want to move the case for DDA and DAs to the bottom here, so that we want to wait until the swaps of letter B's and letter C's to be done, and then we move on to doing the conversions with letter A's. All right, so we do that, and then afterwards we clean it up, right? Let's see if this works. All right, we got it, and this is an under par also. So that's the 3 out of 10 under pars. 7 more to go. Very cool. Let's move on. Next one is a center. So to remind you guys what this one was about, this is about stripping the first and the last letters of the string until you are left with a single letter, and we want to return that letter, the letter representing the center letter of the string. It mentions here that the input length is odd, so there will always be a center letter. And what I'm going to do here is I think I start off by attaching letter D in front, and I'm going to just alternate between removing the first letter and removing the last letter. All right, so it's gonna be something like DA equals, we just remove it, I guess. DB equals DC equals, yeah, all right. And then if you are at this point, that means the letter D is nowhere to be found. So here we move to, here we get rid of the rightmost letter. So we do something like and A equals start D, and B equals start D, and C equals start D. All right. But what if we only have one letter remaining? In that case, it's gonna, if we don't do anything here, it's just gonna remove itself, right? So we don't want that to happen. But if there was just one letter remaining, that means DA, DB, and DC could be at the end, right? It's going to be the entire string. So here's what we can do: end DA, right? We can just return it right here. And the DB equals return B, and the C is return C. So if none of these lines get executed, this means that there are more than one letters, and that means we can safely get rid of the first and the last letters. So we can safely strip the first and the last letters. I think this should work. There we go. So that's all of the overpar problems finished. We can move on. Let's try 4-14 center 2. Nice, that doubling up variable name trick is a super useful breakthrough for saving lines. Yeah, maybe we can even try tripling them, but let's see what we can do with them. Anyway, let's look at this problem. Input a string of A, B, and C. Output delete the letter in the center. So instead of returning the center letter, this time we just get rid of the center letter. I see. Okay, I think what we do here is so what I'm thinking right now is we have a string here, and I'm going to add the delimiters in each side of the string, and I'm going to just keep them together until you either see DAE, DBE, or DCE, and then you remove them, and that's going to be the end result. So the question is, how are we supposed to alternate each of the movements? So that's going to be the question here. And as for now, I do not have much idea. But maybe okay, here's the thing. Maybe we can do this. So we have D and E here. So when you see D, you just move it up once like this. Okay? And then while moving it up once, maybe we can turn that into letter F or something. And then when we move the letter E, one tile to the left, one position to the left, we turn that into letter G or something. And then we convert the letter back to D and back to D, letter G back to E or something. I'm not sure. It's kind of a basically what how I'm going to approach this. The ordering of the lines will be very important though. So let's see. So do this, and then DA equals AF. We do the similar thing with the letter E, I guess. All right, so we want to turn the letters back. So F becomes D and G becomes E, but in what order? Let's see. So we do the D first. Now these are not going to get executed. We move on to this. And then this gets executed. This one gets executed. But now this one will get skipped over, and this one will get executed again. So only letter D will move forward, and letter letter G will just stay letter G. This is not gonna be good. Yeah, I'm not sure how I can safely alternate between the two executions here. I need to think about it. This is not gonna work. But once I can figure it out, the ability to alternate between the two lines would be very useful for the later problems, I think. As of now, I don't have anything. I don't really see any ways to do this. this even work? Doesn't look like it works. Okay. Yeah, hold on. I'm still thinking. First new problem of the day, and I'm already getting stuck. I kind of expected, the problems are going to be only more difficult from now on, but I expected it to be a little more straightforward than that. Okay, this might work. It's a lot of lines though. Surely par is 18. Don't get my hopes up. And it I'm just trying to I'm just trying to get something to work before optimizing, okay? Okay, how about this one? It's still not it? Alright. Yeah, I'm just reading through this debugger to see what I'm where it's breaking. Wait. Oh, sorry. It has to be the other way around. AG becomes GA, BG becomes GB, CG becomes GC. All right. There we go. Wait. Why is it breaking now? Oh, I see. So when there's just one letter, I guess we just get rid of EFG here. Wrong answer. What now? Expected output. Oh, I see. Hmm. That's so many lines though. Oh my god. This one definitely should work though. Alright. Now I have to reduce like 10 lines or something. At most 15 lines. Okay, that's alright. Reduce 7 lines from this. Let's go. Yeah, so the basic idea is we use double letters here to traverse between the lines, and once they move by one index, I just isolate them into just one letter so that they cannot move anymore. And then once the second one, the second action gets done, I insert these this thing at the end, and then only after this one gets added, then now I convert the letter I with letter D in front, so that we just repeat the whole process again. So that was the basic idea. Kind of worked, but All right. Okay, that saved the 3 lines. Got it. I think the next set of optimization would probably involve turning some of these double letters into just one letter. I just need to figure out which one. I have a feeling maybe we don't need a letter G here. But I'm not 100% on it. So what happens if I remove the letter G here? Then it should become something like this. And then these lines get removed. Maybe H, maybe we want to move the letter H in front, so that the letter F doesn't get progressed even further. And I guess in here we just convert the letter H into just start of D. Maybe that can work. So far it makes sense though, and we are hitting the par number of lines. Let's see. Okay, that didn't work. Okay, where's not working? Okay, maybe we need to move it like here or something. The ordering should matter, I think. Yeah, what I say. Cool. Solved it. There we go. I might be able to reduce it even more letters, and get this the under part, but maybe I'll return to it later. But I got the principles right. Yeah, yeah, makes sense to me. Yeah, all right. Let's move on. 4-15 expansion. Repeat the X letter X times. So the first letter is repeated 1 time, second letter repeated 2 times, third letter repeated 3 times. Okay. Okay, that. How do we even approach this? We don't have numbers here. Let's just start by attaching letter D first and then see what we can do. So like D, A, D, B, D, C, they become AD, BD, and CD. Maybe we do some more conversions when we are moving the letter D across. Maybe we attach one more D here, and then like DDA becomes AAD or something. I think this will only preserve the first letter and only double the letters afterwards. So it's just going to become, so the test case one will just become A B B C C, and it's just gonna miss the final letter C. You have to involve something more than that. At the moment, I do not have anything. I'm still thinking of how I can solve this. I'm not thinking of optimizing just yet. I mean, easiest way we can do this is just by um turning them into different letters each time, right? So we can just do like one in front, and just one becomes two, and when there's a number two in front, we just repeat it twice, and then we send the number three afterwards, and for number three we just do the same thing but with one more letter repeated, and then we just do this until number six, because the input can be up to the letter up to six letters. So obviously this is not efficient at all, and I'll probably need to optimize it later, but let's just have something working first. This should work. I don't see how it's not gonna work. This has to work. All right. This does not work. Okay, why? Okay, I see why it doesn't. I need to get rid of number six too. Now it should work. Yeah, there we go. At most 13 lines. All right, let's go ahead and remove 12 of these lines. Let's let's get rid of half of this code. Hmm. Only 1092 test cases. I can think of a 1092 line answer. I don't know about that. Okay. So the obvious optimization here we can do is, we instead of using numbers, we can just do letter D's but repeat it with certain repeated numbers, right? So they will save 5 of those lines. But obviously we need to do better than that. So like I said, if we do it like this, and we need to reverse the orders, this should work. Although it is still a very unoptimized code, but at least it still works. So let's say, like, if we can do this kind of conversions but in a more mechanical ways, so that the same weight can be applied to all of these all of these other cases, then we that's how we can optimize the code. So let me just think of that. So for example, we can do something like, every time you see DA here, it becomes a FAD or something, and then this F thingy gets pushed to the left side of the stacks of letter D's. And after all of that, what's gonna remain is something like this, right? So all we need to do now is turn that into this. There's one more step missing, which is I need to put one extra D here, and that's the only step remaining here. My favorite content is Pangu project. I have no idea what you're talking about. Oh, minigame. I see. This one, right? Your previous student Pangu project. I see. I'll get to it. I'll get to it after I finish this. Maybe we want to add another letter here. Maybe letter E at the end. So what that does is EA becomes FADE. Yeah, something like that. Okay. I think it makes sense so far. Yeah, okay. So we first plant the letter E at the start, and we need to move that one index to the right. Something like this. And then after all that, we get rid of letter E. Letter D and letter E. Yeah. Let's see if this works. It didn't work. I thought my logic was sound. Where did it break? Um, I see. It has to be the other way around. Now it should work. I think it didn't work. Why? I see. I see. I only want one of them to be executed, not all of them. That's why. Hmm. Well, we can just do this then. Yeah. What now? A, E, B, C. Right. We need to repeat this for all of the other letters too. So E, B equals F, B, D, E. E, C equals F, C, D, E. And DA equals FAD, DB equals FBD, DC equals FCD, and finally we do the FB equals BB, FC equals CC. Now it works, okay. Okay, that's all good, but we still need to reduce 3 more lines from here. Like the fact that we don't want the first letter to be repeated at all, it kind of forces me to add some extra lines that um, that's otherwise not gonna be needed. So if I just added the letter E here, then it's just gonna be the first letter gets repeated twice, second letter gets repeated 3 times, etc. So we don't want that happening. What if I simply repeated them here? Would that break anything? So after doing this, mm, so if there was like letter B right here, eventually these will need to become all letter B's. Um, the EA just becomes AA or something? Does this even work? Like I feel like I'm missing something. Hey Kevin, welcome to the stream. Yeah, I've been just solving a couple problems, and it's been already an hour and a half. The progress is not fast enough. I did solve this, but I'm just trying to optimize my way.
Well, here's the sweet shop's answer.
Well, that's a relief. The orderings are still important, and sometimes it's pretty confusing to understand. You know what? I might be able to actually know. Hmm. So what I'm thinking here is maybe I can replace some of these extra letters with repeats of another letters so that we can save even more lines and get the under par. This probably doesn't work, right? Yeah, there's no way. Okay. Maybe if I just repeated this 7 times. Okay, yeah, never mind. I'll come back to it when I feel like I need to optimize this further. Let's move on. 4-16 merge. Merge the two string. Okay, two strings of A and B separated by a comma. Okay, we finally have a different letter than ABC this time. Merge the two strings. Letters from the first string and second string alternate in the output string. Both strings are same length. Okay, I see. All right, interesting. Okay, maybe I want to add some delimiters at the end. Then like, mm, oh, we've done some alternating logics before, so I'm just thinking of doing something similar to that. So something like, mm, Yeah, just check this out. So when I see a letter at the start, something like this, I am moving this at the end, but not just that letter, but also another delimiter. All right. So what this does is, if I can find this letter, this means I am in the middle of the merging operations. So I need to do something before executing this. So if I found a letter E here, I'm going to move this. I'm going to block the starting letter from the from getting picked up. So something like this. I'm going to, so if I found a letter E, I'm going to block the beginning so that these lines do not get executed. Now now I take the second string, something like this. So we have comma A. I want to move this A to the end of the string. So how do we make that happen? I'm going to insert a letter in between. So now you can take this and move it to the end. But I also need to add one more letter at the end. Why? I'm going to get back to it in a moment. So once I see this, I'm going to move the H to the front. Now, after all of these operations, the string will have HF in front. So once you see this string, I'm just going to get rid of it, right? And after all of that, I am going to remove the comma as well. Let's see if this works. That didn't quite work. Let's see. Let's try to debug it now. Probably some ordering issue here, but I need to figure out exactly where it starts going wrong. I see. So these need to, no, this one, this needs to, these ones need to move front, move before the comma operations. Oh, look at this. It's almost working, right? Almost working. Ah, I see, I see. Looks like we'll need to something extra here so that the the starting letters do not get picked up after we finish the operations. Maybe I can just get rid of the start keywords then, even though that doesn't really matter. Maybe I can just do this, I guess. Maybe I can just put HF in front from the start. Let's see if this works. It's working? It's working. We got the achievement once. Complete chapter 4. We will get another achievement once we can optimize this into 9 lines. But this works. So what can I do to make this better? What can I do to shorten this further? How about this? Maybe I can just do FH instead? And like get rid of the H. I mean get rid of the F's in front. No, that doesn't make sense. All right. Wait, why do we have the exact same lines twice? I didn't notice that until now. All right, remove 2 more lines. What was I thinking? Um, Also, what I'm thinking is maybe we can just use the commas instead of everything. Actually, that's not gonna help me reduce the lines. Maybe I can just convert the comma into comma G, and then I don't need to do this conversion. What if I do that? Okay, that also works. One more line to go. Do we even need to deal with the letter D here? I mean, we know for a fact that once the first string gets exhausted, then we know that the second string is also exhausted, right? So maybe we don't need to deal with the letter D at the end. Yeah, there we go. A loop structure in disguise. Complete chapter 4 challenges. We finished chapter 4. There we go. Obviously, there may be some of the problems where we can reduce the lines even further, so that we can get more under pars to go. But I'll think about it later. All right. But yeah. Here we go. We've done it. So I still feel like I can reduce even more lines. So because the thing about letter E is like I feel like I don't need to do anything with these. I can't quite grasp exactly what is being needed. It's also possible that this is as optimized as it can get, but I have no way to know that. This one goes lower. Yeah, I can imagine that. By the way, you don't need to spoil that to me. Okay, we don't have letter Fs anymore, right? Here we go. That's under par. Cool. That's 4 out of 10 under pars. 6 more to go. But can we get even further than this? Because I feel like these two may get redundant, right? So if I remove this, then it's thanks to this line, the merges will happen with the second string first, right? let me think about it. So in here, because once we remove this, the second string will go first, which means I need to move them. Um, Actually, you know what? I don't know how I can get this further. Well, I got the under part. Like I'm not gonna optimize it even further. I have the rest of the games to go. So let's move on. So now it's time to read some emails. So loop structure. So so last time this is what the student sent to the professor. Basically, what this email is about is because what this email is about is the student is kind of complaining, rightfully so, to the professor about their hatred towards this Esolang the student just invented along with the compilers. They were like, why do you not value my creativities and my inventions as much as I deserve? So let's hear what the professor has to say about it. I can't imagine why your relationship is that bad. No comment on the rest. This professor is the worst. They should fire this professor. This is the worst professor I've ever seen. Let's move on. Chapter 5, man, there are not many problems here. Let's go ahead and read it. Proof of Turing completeness. To professor, I just noticed A equals B is Turing complete. We can simulate the probe of Turing machine with a special letter and represent the tape with a string. Given this property, A equals B can handle any solvable problems as long as you don't consider its efficiency. In another word, it can perform all tasks in the scoring criteria. Here we can use arithmetic operations as an example. Course report.pdf. So looks like we have some extra things added to the user manual. Let's read through them together. Compiler's principles course report. Right, like everything in here we already know about. Right, we have some actual proof thingy going on. I don't know if we even need to read through this, but let's see. Proof of Turing completeness is given a Turing machine where Q is a set of states, gamma is a tape alphabet, sigma is input symbols, delta, whatever this is a transition functions. Q theta is initial state, Q accept is accept state, Q reject is reject state. We can represent the table with A equals BC input string, and if we implement the Turing machine with following program, once Q accept equals nothing, Q reject is return reject. For each pair of I'm you lost me. Give me a break. It's been over a decade since I was in the university. I forgot all of these stuffs. Uh, um. Well, let's get back to the game. Count. Input a binary number. Output that many A's. All right. Finally, we get to deal with the numbers this time. I'm excited. So we add the letter D at the end to start with. And what I'm gonna do here is whenever there's a number 1 at the very end, so that's gonna be like 1 directly followed by a letter D. This will translate into a letter A, right? Well, I guess this number 1 will also have to become number 0. Now here I need to implement a the number a binary decrement algorithm. So something like if you see when you see 110, I want to turn this into 101. When there is a 100, I want to turn this into 11. So how do we make this happen? Maybe like hold on, let me think about it. Maybe we turn this into a minus sign and then see what we can do. So 11 minus becomes 101 and 100 minus becomes 11. But in here, maybe this becomes 1 minus 1 and 1 minus becomes 1 minus becomes 0 1. Yeah, so 1 minus becomes 0 1 and 1 and so 1 minus becomes 0 1 and 0 minus becomes 0 and 0 minus becomes minus 1. I think if we do this, we can make it work. I think. And then at the end of everything, we get rid of 0 and we get rid of D. This should work, right? I hope this works. I see. Um, so do this then. That's not enough, I guess. It's like Okay, I thought I was getting somewhere. We got it. In most 7 lines, we just need to reduce one more line from here. Yeah. Hmm. Maybe we can attach the letter A in front instead of at the end. So let's just remove this. And like wait, no, we can't quite do that. Because we can't, because we want to decrease the number and at the same time also add the letter A to the end. So we need to do both at the same time. What if I did this? Alright, I see. Wait, no. Okay, that's still not good enough. Does this even work? Yeah, that's what I thought. Maybe, maybe if I added a bunch of zeros, like 8 zeros, how about that? That's still not good enough. Hmm, maybe I need to put this one first. Yeah, I get it. Okay, probably not gonna work. Hmm. Yeah, I'm not sure how I can optimize this even further. I have no clue at the moment. Okay, that's another way to make it work. So what I did is I literally turned 0 into -1 and kind of just work my way from there. Let's see if this helps me optimize the code. Now this line looks like 1 minus equals 1. It's kind of getting confusing, but mm, What happens when you have this number and then I try to reduce by one more? What happens then? So 0 becomes like this, and then this becomes -1 again, this becomes -1 again, and this becomes -1 again. So eventually the number will look something like this. A leading -1, I mean a leading minus sign, followed by a bunch of ones, followed by letter D, and a bunch of letter A's that are one more than the expected number. So if I can figure out a way to get rid of this in just one or two lines, then we can get to the par lines. Maybe we can do something like start -1 1 equals -1, and maybe -1 dA equals nothing. Maybe if I did this, it might work. Maybe I need to move this somewhere else. Yeah, okay, got it. Yeah, exactly what I thought. I can even do something like this. Now we can just use letter A for everything. Even though it's not gonna change anything. So just changing letter D into letter A does not save any more lines than that. Is there a way to make this even shorter? I doubt there's a way, but maybe. Yeah, I don't really see anything. Let's move on. 5-2 A plus 1 input a binary numbers? You mean a binary number, right? It's just one number. Output input plus 1. Okay. Simple enough. So just add one more, right? So I guess we just start by adding a plus sign at the end. And let's see what we can do in each case. So when you see a 0 plus, it becomes 1. If you see 1 plus, it becomes plus 0, right? And then when you see a start plus, it becomes 1. Yeah? I think this should work. Yeah, that's all we need to do. Simple enough. Reply. Proof of Turing completeness. From Professor. If you've taken formal language course seriously, you should have noticed your so-called programming language is actually a string rewriting system, not something new. People have been working on it since the dawn of computers, and you act like you are completely unaware of that. On the bad side, it shows you have the same poor attitude towards other theory courses. On the good side, at least, it proves that your project is an original work. I can't agree with your attitude, but you do have some ideas of your own. I can say that you have talent, but you struggle in class like people who lack talent. It's a waste. If I were the professor, I would have recommended that this student for a 4 year scholarship or something. I can't believe the way this professor works. It's just, I mean, it's just a work of, fiction, but still. 5-3, a plus b, two binary numbers separated by a plus sign. Output, their sum. Okay, finally we are getting to some actual arithmetic here. So what I'm gonna do here is, you remember how I incremented a given input by adding a plus sign at the end, right? So what I'm gonna do here is I'm going to turn the second number into that number of plus signs, and then just make that many increments to happen. I think that should work. And turning a number into that number of plus signs, we already have that code, right? We have it right here. So we have it right here. Instead of letter A, we want to add we want to put plus signs. But hold on, we already have an extra plus sign. So if we did it like this, then it's going to add one more on top of the sum. So we need to do something else. So maybe we just leave the letter A's like this. And then so during the cleanup phase, we also get rid of that extra plus sign here, right? And then now we do exactly this, but with the letter A instead of the plus sign. Yeah, I think this should work. This is not working. Why? Ah, I see, I see. We don't need to add an extra A here because we already did that part right here. So this one can get removed. Okay, what's going on here? Ah, I see. This one right here. This part needs to get replaced. So we are no longer dealing with the start here because we are converting, we are transforming the second number. So it should be more like plus minus 11, plus minus 11 equals plus minus 1. Now we are talking. Oh, you got it, but looks like we need to reduce one more line from here to make it par. So where do we want to spot the wasted line? Well, mm, let's see. Mm, just one more line, right? Maybe we can turn the first number into a string of plus signs and just attach them at the end. Maybe we can try that. So something like so 1 plus becomes so the plus in here does not represent adding. It's just the delimiter at this point. Something like this. So do this, and whenever there's the letter A here, I'm going to move that to the end of the string, but we are going to attach the letter B here instead. And then we do this operation. And finally, we do this operation. Start -1. It's gonna be plus. No, it's more like this. It's gonna be more like -1a plus, right? Yes, okay. And then in here we increment the second number, but with letter B. Okay, it works, but this is still 10 lines. We want 9 lines instead. But the logic is slightly different, so let's see if this can help us optimize this further. Okay, that still works. Maybe once we can figure out how to clean up the zeros and plus more efficiently. Okay, that's what I expected. So I want to do this increments just one time less without wasting any more lines than that. I don't see a way right now. I'll come back to it later. Let's try and see if the later problems can help me optimize the previous one. 5 days for A minus B. The principle is similar. Looks like the first number is always greater than the second number, so we don't need to deal with the minus signs. Looks like. But I feel like the principle is the same. So we convert one of the numbers into a repeated strings representing the decrements. That works. We need to reduce 2 more lines, and I can already see the optimizations that can be done because unlike the A plus B case, we are decrementing twice, so we can probably use the same logics instead of having them in the separate places, right? So maybe we can just just put them in here instead. And move them like right here. Okay, that works. Easy enough. I wonder if we can uh, apply some more optimizations in this part because we are getting rid of the leading zero here, and we are also getting rid of the leading zero right here. Maybe we can do something here to make the code even shorter than that. We'll think about it later. Let's move on. Proof of Turing completeness. To Professor, can I take this as an affirmation? More importantly, did I pass? A valid question. 5-5. A times B, two binary numbers separated by times their product. Okay? I think hold on. So my gut feeling is that we want to turn this into multiple pluses, and then they turn into multiple increments. But then again, there's a limit of the length limit of 255. I wonder if that limit is good enough. For me, the reductions limit was also a problem. I don't know what a reductions limit is. I don't think I've ever run into it. number of replacements that happens. I think it's supposed to stop infinite loops, but a particularly slow solution can hit it too. I see. So the thing about the binary multiplication is that when you're multiplying by an exponent of 2, all you're gonna do is just add a bunch of zeros at the end. Obviously, that doesn't really help with the when the number 2 multiplies not an exponent of 2. But that's just something I just know off my head. May or may not be helpful. I think we start by copying the first number.
Searching for the thrill, doing everything you can to stay on top of the hill. You say you met someone.
So for example, so for like when you have an input like this, I want to turn this into turn this into this. Or maybe something like this. And then we reduce this number or something. It's not a nice. It's just going to be just 1, but and then after that it becomes something like this, and then we work from there.
If someone wants to tell you what's right or wrong, yeah, they've probably been missing, forgot what they belong. So now I'm picking a card, it says be on your own. Has the lesson been learned? I'm getting ready, let's go. I'm 2 steps away from setting my vision, I know. But now I'm at the clouds of future, I wanna let go. When my head is kinda busy with lyrics and words, I realize that I don't care about the meaning no more. Ay, cause I just wanna stay cool with that. Yeah, I gotta make my living
Oh, looks like it's working. Yeah, I was not really explaining my thought processes, but basically what this is about is um so what I did here is I first turned the right number into a bunch of increments, and then I kept copying them over to the end of the string as I kept decreasing the left side. That's basically what I did. This is taking a while. Is there a way to speed this up? Is this really the fastest it can go? It can go? Like every time I try to verify this, I need to wait like 5 minutes for this. A little too slow. Maybe my code is very inefficient, but I don't think it can go much faster than that. I mean, it's working. I highly doubt that this is going to be the optimal solution. I will have to redo this after reducing some of the lines. About 100 more cases, about 100 more test cases to go. There we go. Okay. The challenge at most 28 lines. Well, look what we did. We did this in 19 lines. This is the first time I actually completed a problem and also got the under par. That's very cool. I thought this is like very inefficient, but apparently I got it pretty efficiently. Now, can we reduce this even further? I mean, it's like any further optimizations of this is a waste of time. But like I'm not very satisfied with what I came up with. Optimized for speed. Can you actually do that? Can this actually be can this actually be optimized for much faster executions? Well, this also works, right? Now it's 18 lines. Do we want to wait through this? Do we really want to wait through all this? It's one more line we used. That's 16 lines. No, 17. Yeah, I'm going to just wait through this verification and then move on. I'm pretty sure this can be optimized even further, but I don't want to sit through this more than twice. But anyway, that's 5 out of 10 under pars. So we need to get 5 more to get the achievement for that. Why is it so slow? I mean, I know exactly why this is so slow, but come on, man. There should be one more level for the speed. Like there needs to be one with 4 triangles. 3 triangles is not fast enough. Halfway there. So slow, man. So slow. 100 more to go. Finally, it's over. Okay, let's move on. 5-6. A divided by B. Alright. Output their quotient and remainder. Alright, so yeah, expecting I was expecting to just get the remainder, but looks like I also need to get the quotient. Okay, this is probably very difficult. But let's see. So as for getting the quotient part, I think we start by, so let's just use the first test case. We have 1000 divided by 11, right? I think I start by adding a comma in front, and then and then how do we detect that there's nothing more to divide? How do we know that the whatever it is dividing is now smaller than like how do we detect that when the left side is smaller than the right side? Because I need a stopping condition. I mean, I know the stopping condition. That is when the thing starts to have minus sign in front, then that's where we know that we do not need to do this this operation, but at that moment it's too late, right? So maybe we need to have a backup somewhere. Because detecting it late is fine for calculating the quotient, but for calculating the remainder, that gets messed up. So let's see what happens uh when we over divide and see what happens. So let's see. I want to divide 2 by 3. So obviously we want to, well, let's increase the right side a little bit. Divide 2 by 7, right? The quotient and the remainder is 0 and 2, right? But at the moment we do not know, so we just blindly subtract the left side with the right side. So it's gonna be something like 1 0 minus 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 1 1 2 3 4 5 6 7, and then it becomes so something like this, right? But what happens if I just don't remove the the leading zeros? What happens then? Yeah, this is not gonna work. Wait a second. Wait, did it just... Hold on. Like, the thing here is, it did result in the correct... Well, I wouldn't say correct, but like this is the number that I want. But I don't know if this is a coincidence or if this is somehow is a right way to I don't know the right wording for it, but so we have 1 0 followed by 7 minuses, and we are just decrementing it. decrementing by like that number of times, and 0 because -1, the minus gets carried over. Now it becomes -1 minus 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 minus, and that becomes wait, no. Yeah, I miscalculated. Give me a sec. Okay, this is what it becomes. All right. That makes no sense. So how do we prevent that from happening? Okay, but if we got rid of the, the leading zeros, then it correctly becomes this. So from this, we need to recover. We need to recover the +2 from it. I guess when this happens, we just subtract from the right side, because that once I do that, that becomes the correct remainder. Yeah, because so what I did is we did a minus b, and then when this becomes negative, we just did b minus this, which becomes minus a. No. So this represents -5. So it's rather, man, this is getting confusing. So it's more like this. Yeah. Got it. Right. So that correctly becomes a. Okay, got it. Right. So we add the comma in front, and then we convert the right side into a bunch of decrements, right? Yeah, hold on. Give me a minute. I need to go to bathroom. I'll be back very soon. Hello, I'm back. Let's continue. So before I actually get to coding, I want to make sure that I got the high level strategies proper. So first of all, I add the comma in front, and then I turn the right side into decrements. And then every time this middle number exists, I add an increment in front, and then we decrement this by this. So we copy this over to here. Okay, so far so good. So that becomes like what is this number again? This is 8, right? So this becomes 5. And then we add another increment. And then we just copy this over one more time. This becomes 2. And then since we don't know when to stop, we keep going. So now it becomes 3, which is incorrect, but just keep going. And then it becomes this. And then that becomes minus. Right? So since there's no number here, this is our stopping point. So once this happens, what do we do here? What do we do now? I think what we do now is we are going to get rid of this pair. So this becomes this, right? Up until comma and the divide sign are together next to each other. So once this happens, now we can convert this this group right here, this group, plus comma slash, all into just a comma. And now we can use these to like add them up or something, right? So that becomes this. I guess we will want to make the right side the plus sign instead. This makes more sense, right? Yeah. So we just get rid of this. All right. And then in here we turn this thing into this. Yeah. All right. But I want to do I want to do something better for the first number. Like I can't figure out a good way to add a leading zero here. Hmm. Hmm. Okay, maybe at this point, maybe do that, and then that, and then just convert that into this, I guess. Might work. All right, let's start. Now we convert the right number into the same number of increments. That should do it, I think. Yeah, exactly. See, the current string, exact. exactly the same as what I want it to be. Okay, now I want to copy the right side into the middle side in the form of decrements, but how can I do that? Hmm. Hmm. Maybe at this point we want to use a different symbol than the slash. Yeah, maybe use exclamation mark. So at this point, I want to wait. No, 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 no. I still want this to be the same slash because I want to repeat this process over and over. So I don't want to switch the symbol just yet. So now here, we convert E plus into minus plus E plus, and then slash minus becomes minus slash, and plus minus becomes minus plus. All right. So after this, well, I guess I want to put this part all the way down so that we don't have multiple letter E's going around, right? To do that, and then at the end of everything, once the letter E hits the end, we just get rid of it, right? Something like that. Okay, let's see if this logic works up until this point. No, that didn't work. Okay, I need to convert it like this instead. Okay. Mm-hmm, mm-hmm. Um. Okay. Yeah, that did decrement the thing. But while doing so, I see. I can use this line to add the increment on the left side. Okay. So do this. Yeah. Okay, perfect. This is exactly what I wanted to see. Except we want to get rid of the comma zero part. Maybe we can do that. So comma zero. Actually, hold on. The remainder can be zero, right? So we can't just get rid of comma zero like that. 태석열님 어서 오세요. Watch this. A equals B라는 프로그래밍 랭귀지가 있는데요. 그것을 이용해서 여러 가지 퍼즐들을 푸는 게임입니다. Alright, how about this? Instead of adding a comma here, I'm going to add a semicolon instead. That way I can safely get rid of the leading zeros without worrying about the case with zero remainders. We are going to be replacing this comma, this quote and unquote comma anyway, so this should still work. Alright. So we are at this point, exactly where we want it to be. So basically we are right here. Now we get rid of each pair of minus and plus. 코딩 게임인가? 예, 맞습니다. 코딩 게임입니다. 코딩 100%의 게임입니다. 코딩하는 것밖에 없어요, 여기. 아, 미니 게임이 있긴 한데 아직 안 해봤어요, 저도. Okay, works so far. Now we just need to implement the increment part, which is easy. So just do this. Wait, what? Yeah. This is exactly what I wanted. So why is it not working now? Yeah. No matter. No wonder. Right. I think we solved it. What's going on? So the second test case worked, but what happened with the third one? All right. At this point, um, hmm. I see. In the case of zero remainders, it's not doing it properly. I see. Okay, that's a problem. Okay, well, how can we deal with that? What can we do here? I guess only when there's a leading minus, only then we take away the one of the increments from the left side. Yeah, maybe if I did this. What now? Oh yeah. We gotta execute this first. Now I think it should work. Almost. So the quotient is right there, but I still haven't gotten rid of the entire right side. I think instead of catching it early, I think I should catch it one step later than that. So how can we do this? So basically what I'm trying to do is I want to, so even when it hits 0, I still want to subtract it one more time so that I have this exact number of the the decrements so that they can cancel out and become 0. Hmm. If- Maybe like maybe if I added, maybe if I incremented 1 on the left side, and then clean them up afterwards, maybe they can work it. So maybe like I need to add one more one-time execution here, so slash becomes plus slash. Okay, what's going on? Okay, now the order of operation is holding me back. This is not gonna work, but I just want to see exactly where it breaks. Yeah, that's not good. Okay. Maybe I just move the exception case with the start plus to the all the way to the end. Okay, so far so good. Now here I want to get rid of the increments, like one increment from each side, I think. So something like that. I mean, it's working, but looks like we are finally getting blocked by the string length limit here. I I'm pretty sure the logic itself works.
Call getting it done. Call me back if you want. All right, talk to you later.
Okay, maybe okay, let me just move around some of the lines to maybe we can reduce the length of the intermediate strings. Why is there so many pluses here? There shouldn't be that many. What's going on? There should be more than 5 pluses in front. Something is going wrong. Alright. Let's debug it. I see. Yeah, okay, makes sense. So we gotta do this, right? There we go. Finally, we got it. That was pretty tricky. Hopefully that's enough number of lines to get us through the optimization challenge. I'm sure the code that I have here can be reduced further, but I don't want to sit through this, like all of these test cases every time. It's taking a while. Achievement complete. Math complete chapter 5. We do not have the optimization achievement just yet because there's one problem that we left off without optimizing. So the par lines is 40 lines. We got it within 23. I would say that's pretty good. Before we move on, let's just read some more emails to Professor. Can I take this as an affirmation? More importantly, did I pass? And the professor's response is, yes, you passed. If this is all you care about, so be it. Go to waste your talent on whatever you want and don't bother me anymore. I can't with this man anymore. All right, let's try to optimize this. Just one more line and we'll be done. But we'll be done with this chapter altogether. Just one more line to reduce. Can you see which line I wasted? I don't see it just yet. Hopefully I can see it soon. So I can move over to the whatever this aftermath thing is. Yeah, I forgot to add the decrement part. Okay, this is not optimal. Okay, this was never going to work. Okay, let me think further. All right, let me think further. After doing this, now I can do the increment part on the left side. So 1a equals plus 0. I mean a0. Yeah, 0a equals 1. And finally, start a equals 1. It should work, right? This did not work, okay. What am I doing? I got the syntax wrong. There we go, okay. Optimized. Turing completeness. Complete chapter 5 challenges. All of the chapter 5 problems fully optimized. I still need to get 5 more underpars, so that's something to keep in mind. Can we get underpar with this one? I do not know, but maybe. Anyway, let's move on to chapter 6, Aftermath. From your previous student. To Professor. Hello, Professor. Do you still remember me? I took your compiling principles course 5 years ago. As the class project, I designed an original programming language, A equals B, and its compiler. I got a lot of guidance from you in that period. I can sense some sarcasm here. I am writing this email to share my recent activities. First, after that semester, I decided to become a game developer. My first work was named as YAP, yet another puzzle platformer. In memorial for Yak, yet another compiler. Second, I had a nightmare about exam week a few days ago. When I woke up from the dream, I suddenly realized that every keyword in A equals B is actually not necessary. I should have passed with my first submission. Course report. Let's see what got added this time. Compiler's principles course report. Draft 6. Blah blah blah. Convenient to code and convenient to code its compiler. Looks like in the chapter 6 we are about to code the compiler itself. This is a work of fiction, and any similarity to actually, yeah, I've already read that. Is that the only addition here? All right. Hello again. Input a string of A, B, and C. Output hello world. You may not use keywords in this level. Ooh, what? I can't use return keyword? Then how? What? What? Doesn't make sense. Huh? Okay, I see what's happening here. Okay. Here's what I'm gonna do. I'm going to turn all of the letters into a single thing. So you see in the test case 1, you see ABC, right? I'm going to turn that into AAA. So B equals A, C equals A. Now there are only 7 different kinds of inputs. So there's AAA, and then AA, right? So now all I need to do is just turn that into hello world. Yeah, I think this is what they want me to do. Challenge at most 4 lines. Okay, looks like I need to actually be smart about it. I mean, I can just hold on. I guess I can just do this, right? Yeah. Alright, there we go. From your previous student. Hello, of course I remember you for your unprecedented solution. In the next semester, we modified the requirements for the course project to prevent more submissions like yours. By the way, you should have noticed the keyword is not necessary 5 years ago. If you did so and proved its completeness in the beginning, I might be angry but would have let you pass anyway. I mean, they passed the student anyway, right? So, and they were angry too, so I don't really see any difference here. Palindrome too. So it's the same problem as before. True or false, based on whether a given input is palindrome, but this time I cannot use keywords. I can't use start, I can't use end. This is going to be a nightmare, I can already tell. Oh boy. So how am I meant to attach anything at the end without using a keyword? I mean, I might not need to do that, but if it's at all possible, that is. Also, how am I meant to turn an empty string into the return statement? I can't do that, right? Like once the string becomes empty, then it's game over. Also, is it possible to do something just once without using keyword? Since I can't escape out of the code with the return keyword, um, I can't use any statements like this. So I can't do empty equals something. I can't do that because this will always execute, and it's going to just ruin the entire thing. I have no clue. I really have no clue. How is this even possible, man? Also, I can't do a equals because at some point false is going to be in the in the string, so I can't do a equals because then the false will get altered. Similarly, I probably can't even do b equals and c equals either. But let's start off with the obvious ones first. So AA equals true, BB equals true, CC equals true. These are supposed to be at the end of everything. Similarly, we gotta do the AC equals false, AB equals false, AC equals false, BA is false, BC is false, CA is false, CB is false. Now earlier in the code, we need to figure out a way to um, strip out the first and last letters from the given string. I mean, like obviously you can do something like we can take all the possible cases. Yeah, all the possible cases. How many palindromes? How many palindromes are there between length 2 and 7? What if I did this? Does this pass? Okay, I guess once the input string becomes false, I guess we can just lock it here with the for false equals false. Or does it just not? Does it just ignore this statement? Like, I want to see if this passes the test case. I mean, obviously it's not going to test the test case, but what I want to see is whether um okay it's lagging right now. Yeah, so what I want to do is ABB equals true and true equals true. Okay, what if I did this? What if I did this? What happens then? I see. Time limit exceeded. The current string is still the same as the expected output, but looks like it still fails. All right. So I guess like the reason why I tested this is because if I can get that to work, then I can alter single letters like this. A equals capital A or something. The reason why I can't do this is because because in the word false there's a letter A in here, so this becomes altered and it will fail the test case. So looks like I am not allowed to make single letter changes. I have to come up with a different method. But again, how many palindromes are there again between length 2 and 7? So these are palindromes. And these are palindromes too, right? So those are all the palindromes up until length 3. Now for the length 4, I guess it's the same thing, but just add one more letter here. And what about length 5? I think there are 27 of them. There's gotta be a better way to do this. You know what? I can run a Python script to generate the code for this. And basically just do all of that, and then after all of this, I want to I want to test. I want to do the false case here. The way I do that is by turning B into A and C into A. I can't convert the letter A because, like I said, false has a letter A in there. So do this, and now we can do this. AA equals false. AA equals false. Well, I guess we can just do this, right? And then AA equals false. Yeah. Yeah, we want to do the longer test cases first. All right. Okay, that's all good and all, but is there a better way to do this? Is there a better way to detect the palindromes without using keyword, without using start, without using end? Okay, hold on. I'm gonna write a Python script to generate the code for this. I got it. That's that's every single palindromic string from length 2 to length all the way up to length 7. So now since the truth case is covered, let's do the false case. Right now this is not going to work because the moment we do this conversion, the moment we do this conversion, uh one of the truth condition will satisfy, and then it will just return true. So I need to do this somewhere else. Okay, how about this? We turn B into capital A, C into capital A. And now we just solve this, and then finally we Mm, so there has to be at least one capital A in the string at this point. And after this, after this operation, it will be just a bunch of lowercase a's followed by a bunch of capital A's, right? So at this point, I just turn AA into A and capital AA's into small a. I mean one capital A, and now there has to be just one lowercase a followed by one uppercase a, right? So this becomes false. What? Oh, I see, I see. We can't even solve the string then. All right. But like I mentioned, I can't turn the letter A into capital A because false has a letter A inside. I need to come up with some different way. Yeah, maybe I can just do this, right? Yeah, and just do this, and then capital A equals false. What now? BBB CCA true CCA. Oh, I see. Okay, that's problematic. All right. I mean, I can literally take every single case into account, which will be like 3,000. It's not infinity. It's just 3,000 lines. I can make that to happen with the help of the Python script. Okay, here's another thing. Um, so another thing that I can think of is, so we have there are limited number of 3-letter things, right? So what I can do here is we just convert 3 of them into a different letter. It's a group of 3 letters into another letter. Like assign each letter to for each of the different groups of 3 letters. But after doing that, maybe I just check for palindromes using those capital letters or something. I don't even know. I have no clue. This makes no sense. What? You know what? Let me look at the other problem. There are only 2 more problems left. To be or not to be 2. Oh my god. Am I supposed to do that without using keywords? Hold on. I can't even. This one feels even more difficult. Maybe I need to implement the equivalent of the keywords without using keywords. Maybe that's what I'm expected to do. But how? What if it repeated every puzzle in the game and had you do every one without keywords? I mean, like, is every puzzle in this game, solvable without keywords? I mean, like, the email conversation, the email exchanges does suggest that it is possible, but I don't know. Like, the only thing I can think of with this problem is just get all possible inputs and just assign true or false based on each of the 3,000 or so test cases. I'm sure parts 3001. Yeah, I'm sure about that. There's not much I can do here. I can't use start and end keywords. Those are essential for this problem. I need start and end. Like, I'm looking at this Turing machine thing in the user manual, and even here they are using the once and return keywords. They should have given a censored version of the manual for the last chapter with everything blacked out. Sorry, I don't understand what you mean. Since they keywords aren't usable anymore. Yeah, sorry, I don't understand. Like, when the government releases classified documents with whole pages just black lines. Again, I don't see your point. What does that accomplish? How does that help with my case? Oh, it doesn't help. All right, okay then. I thought you were trying to be helpful here. It'd just be a joke. Yeah, sorry, I didn't get it. I guess I can add a letter at the beginning by doing something like this. So AB equals like start capital A, capital B. So do this, and obviously do the same thing with all the other combinations of the two letters. Do this, right? And then I can move these exclamation marks to the front by doing this. So now there are one or more exclamation marks in front, and the rest of the input string is the same, but some of them are in the uppercase instead. But maybe I'll fix them later. But right, but after this, I can um, turn two exclamation marks into one. Now this now we have exclamation marks mark in front. So what can we do from here on? I mean, I guess we can also fix the remaining lowercase letters by doing something like this. Yeah. right? So now all of the input cases are capital string now. I guess we can also add another symbol at the end. Let's say question mark, and move question mark to the right side. You know what? Maybe when you're just moving the symbols around, maybe this is where we can capitalize the letters. So all of these lines are not necessary. All right. So now the entire input is capitalized. That there's the exclamation mark in front. There's a question mark at the end. So now what I'm gonna do is check for the case with 2 letters. So this is true. So with this out of the way, now we can move the first letter all the way to the end and see if they match. All right, do this, and then at the end we will have this, right? Hold on. So do this. So what I am doing here is So when there is even number of letters in the input, each pair will become either true or false at the end. If there are odd number of letters, it's going to be some number of trues and falses, um, and a single letter in front of it. So after doing all of that, we are gonna turn the letters back into lowercase. All right, so do that and repeat the process, and in the end, it's gonna be like it. And in here, it's gonna look something like a true, true, false. So now here we are going to reduce this result into either true or false. So first, true, true becomes true. True, false becomes false. False, true is false, and false, false is false. And now we get rid of the a single letter at the beginning if there's one. So a true equals true, b true equals true, c true equals true, and a false equals false, b false equals false, and c false equals false. Let's see if this works. Wait. Get rid of this line. Right. Is that not it? Why is... Right? Ah, I see. Yeah, I forgot to add the sorting between the exclamation marks and question marks. So I had to add this part. Alright. Okay, what's going on now? So far so good. This is exactly what I wanted to see. So it's now exclamation mark A, B, B, A, and question mark. Now I want to move the exclamation mark A to the right side. Oh, I see. Okay, that's a problem. Maybe I need to introduce another symbol then. Okay, how about this then? And I guess I need to do the same with the existing @ signs. And then do this. Okay, and then that becomes true. Now we turn the letter B's back into lower cases. Now that becomes that. Oh, I see. Okay, I need to do the same with the exclamation marks then. Holy crap, it actually works. I'm sure this is like extremely unoptimized. I'm sure like the actual challenge will require like 15 lines or something. But hey, it does work. Can't believe I made it to work. Like I initially had like absolutely no clue. This felt like an impossible test, but apparently it's possible. Wasn't the first one of the chapter 40 or something? I don't know, man. Alright, that is done. Challenge at most 24 lines. Okay, I have a long way to go. That's 73 lines, right? Maybe I can save some of the lines, so maybe I don't need to declare everything, absolutely everything here. maybe I don't need to deal with question marks. Hmm. Let's say I don't use question marks. So do that. So all of these lines can be removed. And this one. And then like we move these lines up here, and then we remove question marks from these conditions or something. Wait. Has to be the other way around. Wait. So, so at this point right here, mm, wait, no, I still want to, uh, I see, all right. So once I moved the first letter all the way up, now here we can detect the palindromicness by checking letter at sign letter. Yeah, we can do that, right? And I guess the conversion will have to be at the very beginning. So move these all the way up here. Okay, that passes the first test case. What about this one? Wait a sec. No. Okay, where did it go wrong? Okay, that's all good so far. I see. Maybe I can just put explanation signs around everything. Maybe then it'll. Okay, that's still not enough, huh? I guess I can just add these lines. Wait, what's going on? Why didn't that detect the thing? All right. Now we. Oh, I see. Well, we don't want to see that. I mean, at the end, I need to do all of these within 24 lines. So maybe I just need to come up with an entirely new logic. I see. It slightly improves things. I went from 63 lines or something down to like 40 lines. So we still need to reduce this into almost half of that. But it's a progress. It's an improvement. It's 48 lines, down from 73. We need to exactly halve the number of lines here. Uh, uh, do we even need to turn things into capital letters? I probably don't even need to do that, right? Actually, yes, we do, because otherwise we are gonna infinite loop. So never mind. All right. How do we take away half of this? What am I missing? What am I over computing here? Maybe at this point we can just turn the at sign into false. And then like something like that. So once it finds anything that is a false, then at that point we can simply, yeah, do this or something. Why doesn't it not work? Right, that's, wait, what? What happened? A, B, false. I see, I see, I see. So gotta move this all the way up here then. Okay, that's a true. And now, oh, I see. So we don't want to see that. Maybe we want to move this to like right up here. What's going on? Okay, this seems to work. Wait, no. What happened? Hmm. Maybe I need to do this comparison instead. Why is it only sometimes working? Hmm. I think I know what's going on. Maybe it works. I don't know why I'm struggling so much on this. I mean, probably this is supposed to be one of the hardest, one of the hardest problems, but I still don't feel like it should take me this long to solve it. I mean, I already solved it, but I'm just trying to make it fit within 24 lines. and I'm still not even close to 24 lines. Okay, that worked. So that's down from 48 lines, but this one probably can be optimized further due to the way it is structured. Okay, that works too. Yeah, we don't need to go through we don't need to go through all of the test cases. Well, at least until we get to we get close to the power lines. So let's continue. All right, that's a few more lines optimized. How many lines is that? That's 40 lines, all right. Maybe we can move them all the way up here. Yeah, that works too. Maybe I can even turn the S sign itself into false. Okay, that's not good enough, I see. Okay, that's 40 lines, right? 16 more lines to shrink down. Oh boy. I feel like I don't need to use the question mark though. Yeah, alright. Question marks are not needed, looks like. So that's gonna save a bunch of lines, right? What happened? I see. Still want to do these things, I guess. Alright. That's still not good enough. That's gonna work for sure, right? Yeah. Okay. How many lines is that? That's 36 lines. 12 more to go. Well, 11 more to go. So we got rid of question marks. Alright, hold on guys, I'll be back in a moment. Alright, I'm back. Let's reduce 12 more lines and we'll be good to go. I guess we can optimize one line from this. That's very minor though, but still, a line is a line. 10 more lines to go. Well, I'm running out of ideas at this point. What more can I do? I need 10 more lines reduced from here. I feel like I'm at the absolute minimum. Do I need to come up with yet another logic? Mm.
I remember the time we spent together. When love is like addiction, if love is like emotion. I remember the time we spent together. When love is like addiction, if love is like emotion.
So we only need one exclamation mark in this case. Mm. So what I'm going to try this time is I'm going to take two pointers from each side of the string, and then just gradually squeeze them down to the center. Then I'm going to evaluate the palindrominess from the center out instead of going from the outside inwards, which was what I've been doing up until now. But this time I'm going to try from the inside and try to expand outwards. What's the current line count? The current line count is 34. So I am 10 lines away. But I'm trying out a different strategy this time. Yeah, this strategy also works. Though when it comes to line count, this is even less efficient than the current best that I've come up with. 44 lines. Hmm. Okay, that still works. Yeah. Yeah, sorry about not being able to commentate much. There's nothing much I can explain here. Like I think I need to just come up with something that works. I mean, this one obviously works, but I want it to work within 24 lines. Once I come up with that, then I'll try to explain exactly what's going on. But for now, all I can do is just think internally or something. I can't really explain everything here, and it's most likely not the right approach anyway. So there's really not much of a point for me to explain.
What you think of that?
All right, that's a new PB. The 33 lines. I just need to reduce 9 more lines. Um, Nothing much to explain. Like I said, I'm gonna wait until I actually hit the power lines before I actually explain what's going on. It's one more line reduced. Good luck with your optimizing. I'm off to bed. Yeah, yeah. Thank you for visiting, and I certainly need luck. I don't know why it's taking me so long. Like, I should have been done with this game hours ago. I don't know why I'm still stuck in here. Pretty sure this is the hardest one. There is one more problem after this. So I don't know. Probably not going to be finishing this by today. But I'll try to finish this problem at least. But anyway, thank you. let's save some lines for sure. So what I did here is by adding this @ sign, I can simply assign this @ sign to false and not need to worry about assigning any other letters to the false. So basically this saved the basically this optimized the lines for assigning the false cases. So now I just need to reduce 5 more lines and we'll be fine. Alright, well, I did get it down to 29 lines, but I think I'm just gonna call it a day. I'll try to optimize it further offline, or tomorrow, or whenever I have time to take a look at it. But as for the streaming goes, I can't let it become any more boring than this, and also it's getting pretty late, so I gotta go to bed. So yeah, that's about it for today. Yeah, I've been streaming for 9 hours. That's a lot. I should actually cut down on it, but probably next stream will be the last one, considering that I only have one more problem after this. So yeah, thank you for visiting, everyone. Thank you for watching. I'll be seeing you guys next time. It could be tomorrow, it could be in 2 days. We'll see about it. All right, have a good rest of the day. Bye bye.